Hello and welcome to lesson 10.2 where we are going to be talking about histograms today. Histograms are just another way to display data in a graph. So if we look at our definition here, which you should write down, like I said in our last video, so you can have it for notes on your quizzes and tests. A histogram is a bar graph that shows the frequency of data values in intervals of the same size, and the height of the bar represents the frequency of the values in the interval. So let's make a little bit of sense out of how a histogram is different than the bar graphs that you probably saw, well, before now. So here is a very typical bar graph in which you can see along our x-axis here, we have data displayed in even increments, and in this case they're going up by ones from 0 to 1 all the way to 7. And then over along our y-axis, it's the number of weeks. So this also go up by even intervals, but they're going up by 5. So 0 weeks, 5 weeks, 10 weeks, 15 weeks. We can interpret this graph to read that 2 of the weeks in 2006 in Auckland, they had 0 rainy days. 5 of the weeks, there were 1 rainy day. 5 more weeks, they had 2 rainy days, and 5 more weeks, they had 3 rainy days, so on and so forth. You can interpret this graph simply by looking at this column here, that they had 20 weeks with 4 days of rain. So you can easily see that 4 days of rain was the most common number of days of rain in any given week. So if we take and see how that's different than a histogram initially looks very similar. You still have your x-axis with your data value, and then the y-axis, in this case you have number of people. But in addition to a bar graph, whereas a bar graph you have nice even increments, and in this case they go up by 1, sometimes that just doesn't make sense. And so you're going to have ranges. So here you can see that instead of going up by 1, 2, 3, or even 2, 4, 6, they're going by ranges. So if we're talking about the number or the ages of people at a family reunion, you can see that we have age ranges all the way from 0 to 89. It would not make sense to make a graph that went up in increments of 1. The graph would be huge. And so instead, they put them into age ranges. And notice the ranges still stay with the rule of keeping an even increment. So 0 to 9 has 10 intervals, 10 to 19 has 10 intervals, 20 to 29 has 10 intervals, and so forth. Along here is our frequency. So you can see that the number of 0 to 9-year-olds that were attending this family reunion, there were 8. The number of 10 to 19-year-olds, there were 10. If you were trying to answer the question of what was the fewest or what was the least, the lowest age range, you would say 80 to 89. They had 1 person attend that was between the range of 80 to 89 compared to the 20 to 29 age range in which you had 18, and that was representing the most number of people within an age range to attend. So a histogram, again, being very much like a bar graph, instead you are working with evenly spread out intervals to show the frequency of an event. All right, so on this example here, we've got the number of laps that were the people in a swimming class completed in a day, and we are going to look at how we can display this data in a histogram. So I've already got the data chart kind of set up for us. I knew that we were going to have 5 intervals because we had 5 intervals up here. And then my frequency, my highest number was 11, and I didn't want to go 0 to 11. I thought that would be too small on the graph, so I decided I'm going to go up in increments of 2. And so the first thing we had to do was label our x and our y axes. So along this axis, I will put the range for the number of laps. So this bar will be 1 to 3, 4 to 6, 7 to 9, 10 to 12, 13 to 15. Please notice once again, each of these are going up in even increments of 3. 1, 2, 3, 4, 5, 6, 7, 8, 9. Our 0 is always going to be here at the corner of the vertices where our axes meet. And then I'm going to label by 2's on the line, not in the space. So 2, 4, 6, 8, 10, and 12. So from here, I can just look at my frequency and I fill in my bar graph as necessary to represent the data. So the frequency of people who swam 1 to 3 laps was 11. This is why it's kind of nice to keep your frequency numbers in the smaller ranges. And you can just fill it in like that. Okay, between 4 and 6 laps, we had 4 people. So fill it into there. Now 7 to 9, there was nobody who swam between 7 and 9, but I still keep it as a part of the graph. So 10 to 12 had 3. So once again, I just split that right down the middle. And 13 to 15 had 6, so that goes right up there to that line. And fill it in like that. Your graphs, of course, will be much prettier. You'll use color and you'll fill these in a lot nicer. All right, so looking at how we can use a graph to interpret the data. So this is representing the age of people who are on a roller coaster. So we have, again, even increments. We have 10 to 19, 20 to 29-year-olds, 30 to 39-year-olds, 40 to 49-year-olds, and 50 to 59-year-olds. My ages are the ones being broken up into those intervals, so that's going to be my x-axis title, and then my y-axis title will be frequency. If I look at the highest data, I've got 16, and so once again, I'm going to try to go up by 2's, start here with 0, 2, 4, 6, 8, 10, 12, 14, and 16. And you'll just fill it in just like we did on the last one. So this one goes all the way to 16. 20 to 29, the frequency is 11, so you just mark that off here and fill that in. 30 to 39, we've got 5. 40 to 49, we have 2. Oops, right here. 50 to 59, we've got 4. Okay, so again, just practice filling in that histogram. And again, the difference between a traditional bar graph and a histogram is we are working with intervals rather than just single-digit numbers. And now we can start to answer some questions now that the graph is filled in. So you can easily see within a bar graph which values are the least, which values are the most. So question 1, which interval contains the most data values? So I would simply just look for the interval that has the highest bar, and that would be the 10 to 19 interval. How many of the ages of the people on this roller coaster are under 30? Well, I wouldn't count the 30 to 39 because it needs to be under 30. So I can see that 20 to 29 is 11 and 10 to 19 is 16. You add those up and you would say 27 people. How many of the ages are at least 40 years of age? At least, meaning 40 to 49 will work because at least 40. And then 50 to 59 is another 4. So you've got 6 people on that roller coaster who are at least 40 years of age. So again, putting things into a histogram or a bar graph such as this, you can easily answer certain types of questions. Now there are going to be other types of graphs that you come across that are going to be able to answer some types of questions better than others can. So these two graphs are both showing push-ups done by the number of students in a class. With our top graph here, our percentage chart, you can see that 12% of the students did between 0 and 9, 20% of the students did between 10 and 19, 40% were between 20 and 29 push-ups, 24% did between 30 and 39, and then 4% of the students were able to do between 40 and 49 push-ups. Okay, what this graph doesn't tell us, that this histogram down here does, are the number of students. So now we can see a little bit more data. So this 12%, which was 0 to 9 push-ups, we can now see on this histogram chart that 12% of the students is 3 students. Okay, nowhere in this chart did it actually tell us the number of students that these percentages represented. So even though we're displaying similar data, there are certain types of charts that are going to be more beneficial depending on the information that you need. So we can make conclusions from these data displays. So if we had certain questions like these 4 that we needed to answer to determine if they were true or false. So which statement cannot be made using the data displays? Okay, well, this first one says 12% of the class completed less than 10 push-ups. So I'm talking percentages, so I wouldn't use my histogram chart. I would come up here and use this chart. It said 12% of the students completed fewer than 10 push-ups. Okay, well, 10 push-ups wouldn't be fewer, so I would just be looking at this blue section, and it's 0 to 9, 12%. I can say, yes, that is a true statement based off of the information in this graph. So I would give that one a star. It is a true statement. Can I prove this one? 5 students completed at least 10 and at most 19 push-ups. So I wouldn't use my percentage pie graph here. I would come down here because it's asking for number of students, and this is the only graph that shows us how many students. So again, we are looking for 5 students completed at least 10 and at most 19 push-ups. 5 students completed at least 10 and at most 19. So I would look at this orange piece here, and we've got 5 students. So again, I can say that this is a true statement. At least 1 student completed more than 39 push-ups. Again, I would come down to my histogram. At least 1 student completed more than 39, so I wouldn't look up to this green. It has to be more than 39. Between 40 and 49 push-ups, I have 1 student. So that one I would say is, again, a true statement. And this final one, 29% of the class completed 30 or more push-ups. I would come back to my pie graph here with the percentage chart. 30 or more push-ups. Well, I've got 24% who completed between 30 and 39, and another 4% who completed between 40 and 49. 24 plus 4 is 28. And this says 29% of the class. So this one would not be a correct statement. So that is just an example of how you can start to use these data displays to answer different types of questions. And hopefully it illustrated how some types of data displays are better at answering certain types of questions better than others.